Orang you all macam baru separuh je masuk ni. Kita tunggu sekejap bagi orang lain masuk dulu dalam kalau number of students dalam 45 ke 50 tu saya start kelas. Sekejap
Boleh doktor.
You all ada kelas apa tadi? 8 sampai 12 tu? Penat semacam je masing-masing
Oh, ada presentation bagi tadi pukul 8.
Budak-budak insomniac.
Dia macam bangun awal tu macam prepare.
Yelah,
So,
kalau
jadi penat.
sekelas kan macam tak payah nak prepare sangat kan. Macam you tadah aja apa benda lecturer aja.
Betul.
Okay, saya pun ada presentation juga pagi-pagi pukul 8 tadi.
Wah, Amirul.
So,
ni,
faham?
Makan. Aku ajak.
Okay, now dah 40. Tunggu sekejap. First of all,
Makan Pak Gebus.
I would like to share with you guys a few things. Saya ada dokumen. Saya ada buat satu PowerPoint and I have another one tu dalam bentuk yang tulis tangan. Notes. Tak ingat ini waktu 610 ke machine learning dulu. Memang I buat notes ni. So kalau you nak bolehlah saya bagi kat sini the hold out method apa, cross validation method and the differences between hold out method and also K4 bila nak pakai, and then I also explain kat sini tentang the random and also stratified sample. Sekejap lagi kita tengok. These are the things yang kita akan tengok sekejap lagi. Okay.
Oh, dia sekali yang tapi asing alamat guna kad kau.
Slides, nanti saya bagi dekat you all. Saya ambil juga nota daripada ambil nota daripada Dr. Rohaila punya notes. Yang ni. But I add a little bit some info lah untuk you all. Okay. Kita tengok berapa orang dah, 42. Jomlah kita record. Nak tunggu lama-lama pun macam penatlah juga kan menunggu. Okay, so let's start our class. Okay, Assalamualaikum. And today we will continue our lesson with chapter 3. Like I said last week, we have two parts for chapter 3. Both are analytic methods. So last week we have learned about the types of analytics. We have seen the the methods that the methods that we always use for to do analytics kan. So for today we are going to look at the evaluation metrics. Okay, how to evaluate the models. Last week dah tengok dah models. What are the models that can be used for to do this analytics, especially the predictive analytics. So now let's look at how to evaluate the models. I believe that you have learned this in data mining. So mudah untuk you faham, cepat sikit lah. Okay, so there are two things that we will learn today. First one is the types of evaluation metrics and the other one is how to evaluate the model. Okay, so first thing first, let's look at what is evaluation metrics. So evaluation metrics is actually used to measure the quality of the statistical or machine learning model. So we know that overall machine learning models tu dia ada statistical approach, ada AI approach kan. So we need to measure that because there are also some statistical model being used for prediction macam ARIMA everything kan. So what are the evaluation metrics that can be used to measure your model, whether the model is accurate or and reliable. Okay, so this evaluation metrics is actually a core part. Okay, when you want to develop a machine learning model. ataupun macam nak develop the reliable and also effective machine learning model. Okay, kenapa I cakap core parts? Kalau tak ada evaluation matrix, how are we going to measure whether our solution, our model tu is correct? Okay, so I've listed a few evaluation metrics for the two common machine learning tasks, which are classification and clustering. So for classification, people always use accuracy, recall, precision, F1 score. Sometimes they will see the difference between recall and precision, but again, in certain condition, kadang-kadang you perlukan that one. These two to support the justification ataupun the results that you obtain. And then you can also use decision threshold. You can also use ROC curve. Okay, ROC stands for receiver operating characteristics. And as for clustering, kalau kata K-means tu, we always look at the accuracy kan. Tapi kalau kata clustering, yang pure clustering tu, statistician always use elbow method. So dia akan tengok the SSE produced using elbow method. They also use silhouette coefficient or a dance index. Okay, but how to calculate this one? So kena investigate more lah. We are going to look at the confusion matrix saja untuk this subject. Okay, saya nanti kalau you belajar statistik 404 macam tu dia ada kan, dia covers I think. Elbow method ada pernah belajar tak?
Aku ada 400 cash kali.
Kalau kata pure statistics punya students ni, dia memang kalau dia buat clustering, they always use elbow method. Especially for example kan, kalau K means computer science students, dia buat macam more to experiment. Kita try a few numbers of K, and then we will observe the accuracy produced by the model kan. And then kita akan tengok precision juga, and then tengok tengok apa kata we will see on the results. But for clustering, kalau kata statistics students ni, dia akan tengok SSE, the sum squared error, dia akan plot dan dia akan tengok, dia akan gunakan elbow method. So which values yang produce the lowest, if I'm mistaken the lowest value kot, then dia akan ambil. Kalau kata contoh untuk K-mean lah, which number of K yang produce lower SSE.
Dapat 50 sen.
So dia adalah cara-cara dia, silhouette coefficient pun sama juga. And sometimes they can use this elbow method together with silhouette coefficient to support the results. Okay, sama juga macam classification pun. Kita kadang-kadang kita tak pakai accuracy sahaja. We need other things like precision and also recall untuk support kita punya accuracy. In case you punya accuracy tu a bit low, so you boleh keluarkan the precision and recall. Even though accuracy low, sometimes precision and recall dia tinggi. So itu akan menentukan whether the model is acceptable or not. Okay, perform very well ke tidak. And then so using this evaluation matrix, we can measure how accurate our model will be, and then what are other things, other metrics that can be used to support our our results tu. Macam cakap tadi tu lah, kalau kata accuracy low, then you might need other metrics to macam precision, macam recall. Lepas tu nanti you akan tengok kan, dia ada specificity. Okay, you can use all those all other metrics, ataupun you boleh juga plot dekat ROC curve untuk measure. Kalau kata you come out with a few models and you would like to see which models that perform well. Okay, so you can plot the ROC and then look at the curve, which one yang you rasa better. Okay, so for this evaluation, you need to use the test set. Previously ada students yang kata, oh tak madam, ini accuracy untuk training. Accuracy untuk training tak ambil kira. The final accuracy that we will always look at is the test set punya accuracy. So you need to use your test set, unless kalau you pakai K-fold. K-fold tak adalah kan test set, because we know that K-fold dia every iteration tu dia akan dia akan ada testing and training set. Okay, so the method for estimating the classifier's accuracy that people always use the first two, hold out method and cross validation, but you can also use bootstrap. Okay, hold out method ni yang split ratio tu lah, yang that you can split your data set into 2 or 3 parts. The first one is the training, that one is wajib. Testing also wajib, and you can have validation. So validation tu can comes in between training and testing lah. Okay. Usually validation will be used for parameter tuning macam tu. So test is memang confirm untuk testing. So you kena take out and put aside itu tu. And for that split ratio also, if you look at the RapidMiner, there are a few configuration. Okay. Dia ada automatic, dia ada random, dia ada stratified. Okay. And dia ada linear, sorry if I'm mistaken, ada linear. Linear dia ada difference between these 4 types of hold out method in RapidMiner. So kalau kata you ambil split ratio tu, you click dekat split ratio operator, you will see type of splitting tu. Dia ada 4 yang cakap tadi, auto yang you leave it to RapidMiner to split your data. And then we have linear dia akan ikut, kalau kata you nak split into 80 and 20, so the first 80% of your data set will be will be reserved for training and the other 20% for testing. So kenapa linear? Sebab dia akan ikut sequence data tu. So the first 80 training, the remaining one is for testing. But for random dia akan randomly pick 80% from your data set to be in the training set, and then another 20% random untuk testing. Okay, untuk stratified, it is similar to random. However, this stratified is basically they remain the percentage of the class. Okay, this one yang saya nak kena tunjuk because I've sketched this. Sekejap Mana dia? Okay, I nak tunjuk kat sini. Kalau random, ini sorry ini I conteng-conteng je hari tu. Kalau random, you boleh guna, tapi kadang-kadang contohlah kalau kata data you well distributed 50%. Kita tengok dekat sini Yang ni. Okay. Kalau 50-50, so boleh pakai random, tapi dia akan pick randomly lah. Maknanya 80% daripada the whole data set. Okay, I rasa random tak ada masalah. Stratified tu yang kadang-kadang students agak confused. Okay, stratified kalau kata kita ambil ni dulu. Okay, sebelum I pergi yang ke atas ni. Kalau 50-50, dia akan make sure, sekejap, nak tulis. Sini. Okay, if 50% ni punya data, dia akan make sure training set akan consist of 50 from class A and 50 from class B. And testing set pun sama juga. Okay, katakan you nak buat 80% kat sini. 80%. Ini kalau lah you punya data you balance. Balance maksud saya kalau ada 2 classes. Okay, 2 classes yang kata class A and B. Okay, you have class A and B. A 50%, B pun mesti 50%. Ini pun sama juga. 20% that consists of A 50%, B 50%. Ini kalau stratified Okay. Ni first condition. Balance dataset. If you have imbalance dataset, okay, contohlah you have two classes yang sama juga. Okay, let's say the first data you ada 70%, 30% class A and 30% class B, okay? And you would like to split your data set into two parts juga, 80-20. So dalam 80% ni you remain percentage A 70%, percentage B 30%. And untuk testing 20%, A mesti ada 70% and B kena ada 30%. Okay, this is stratified. Kalau random dia tak peduli. Lantaklah kelas A, kelas B dia akan pecah 80-20. Kadang-kadang mungkin kelas B dia punya number of data untuk kelas B tu terbanyak dekat dalam training, testing tinggal sikit. Jadi itu akan kacau sikit lah you punya performance of the model. Okay, so based on my experience, kalau nak pakai, especially when you have imbalanced data set, so please use stratified punya method untuk split ratio. Okay, cross validation tak ada masalah. Cross validation sebab you memang buat k-fold kan, you pecahkan kepada beberapa k, beberapa fold, and then you akan rotate benda tu. Siapa akan jadi training, siapa akan jadi testing. So each of the fold tu akan merasa untuk jadi training dan juga jadi testing. So, okay, tolong ingat benda ni. Dalam nota dalam nota slide ni tak ada. Tapi kejaplah I just snapshot benda ni. Kejap, bukan snapshot. Tak ada. Sekejap. Okay, so saya letak je kat sini. This is for stratified. So nanti saya akan bagi dekat you all dua-dua dokumen. Okay. And for comparing classifiers, you boleh pakai confidence interval, or you can also use cost benefit analysis or ROC curve. Okay, like I said, if you have a few models that you want to compare, so the best method will be ROC curve lah, sebab bila you plot tu you akan nampak which one yang better, give better performance. Okay, next is the confusion matrix. Okay, confusion matrix ni I rasa you all dah biasa kan, you dah biasa dah macam mana nak come out with the confusion matrix, how to calculate the accuracy, or how to calculate the error rate, how to calculate the sensitivity, specificity, everything. Dah belajar kan dekat dalam data mining?
Doktor, selepas belajar dah.
Okay, senang lah. Jadi for confusion matrix you dah tahu kan, usually we use for classification, for prediction, we would like to see actual versus predicted ataupun classified punya classes. Tengok sama ada betul ke tidak dia predict ataupun dia classified the correct class. So there ada a few terms here. We have true positive, we have false negative, false positive, and also false negative. And each of these, I hope you guys boleh beza apa dia true positive, apa dia false negative, false positive and true negative. Salah, patutnya baca true positive, false negative, true positive. True negative. Okay, so accuracy, I said ini pun you all dah belajar how to calculate the accuracy. You will take the true positive and true negative, okay, divide by the total number of data that you have. Meaning that kalau total number of data tu dia akan include TP, TN, FP, FN. Okay, and the error rate will be 1 minus accuracy. Okay, ataupun kita ambil lah FP tambah dengan FN divide by total number of data. Okay, if you still can remember, tak apalah, kita refresh je lah. True positive apa? True negative, false positive, false negative. So true positive is where apa kata, where we want to predict yes, so memang model kita predict sebagai yes. Okay, true negative, dia sama juga macam tadi lah. Tadi kita predict yes, now kita predict no. So memang dia correctly predicted benda tu sebagai no. So false positive, we predicted yes. However, apa kata, dia akan apa? Dia kata apa? We don't actually have the disease. Okay, predict yes tapi sebenarnya tak. So false negative, predict no tapi sebenarnya apa? No lah kan? Yes. So this is how to calculate. Ini kena ingat sebab dalam final exam ada. Ini saya ada bagi tu sample questions from previous semesters. Kalau you nak tahu lagi apa sample question, you want to get more sample question, please search in QBS lah. So sekejap. These are the how to calculate the accuracy. So accuracy, kalau kata in this case, total number of data that we have is 165, and then our TN is 50, FP 10, FN 5, and TP is 100. Okay, ini memang kadang-kadang confuse sikit, so you kena label betul-betul. Ada some of the students, tak kata students lah, saya pun kadang-kadang terconfuse juga, because you have to look at the label. Actualnya yes dengan no dekat mana, and predicted yes dengan no dekat mana. Okay, try to match label dulu and then baru calculate. Because I can see ada few semesters dah benda ni jadi, some of the students dia salah ambil value. Jadi sagi kira specificity sepatutnya sensitivity, dia macam itulah bila dia tertukar-tukar tu. Okay, so accuracy, kalau kat sini we need to take TP. Kita draw sikit. So we need to take TP, okay, 100. And TN, okay, plus 150 by 165, so kita akan dapat 91, 0.91. Okay, you boleh tulis dalam ni 0.91, lepas tu boleh buat equals to 91% pun boleh juga. Okay, so misclassification rate is either you want to calculate macam ni, FP plus FN divided by total, or you can just use 1 minus accuracy, dapat misclassification rate pun boleh kalau dekat dalam exam. Okay, so saya terima dua jawapan tu. And then true positive rate, so you kena ambil lah true positive rate, TP, okay, TP which is 100, you divide by 105. Kenapa 105? Sebab kita akan ambil, dia nak true positive rate kan, kita kena ambil actual yes. Actual yes-nya berapa dan yang dipredict sebagai yes-nya berapa. Jadi 100 over 105 dapat 95%. Okay, so kalau kata nak with 91% accuracy, you boleh kata strong lah sebab dia ada 95% sensitivity ataupun recall rate dia. And then false rate, FP divide by actual no. So actual no 60 kan, our FP is 10, so 10 divided by 60, you will get 0.17. So sama juga sensitivity, how sensitive it is, bila dia kata when it's actually no, how often it will predict as no. So true negative ni divide by 60. So 50 over 60, 0.83. Okay, and precision when it predict yes, how often it is correct. So 100 over 110. So you will get 91% juga precision. So prevalence, actual yes divided by total, you akan dapat 64%. So each of these apa kata matrix ni, dia ada kegunaan dia lah. So tengok dekat mana bila masa yang you nak guna pakai. But people always use 4 benda. Accuracy, And then we use sensitivity, we use specificity and also precision. So 4 benda ni yang selalu ditanya dekat dalam exam. Okay, this is the precision and sensitivity. How does these two the difference between these two, precision and sensitivity? So kalau you tengok dekat sini, precision, how precise dia dia predict, okay, yes, kalau diberi yes, kan, so dia akan tengok on the positive columns. But untuk sensitivity, okay, dia akan tengok ni lah, sensitivity will look at the yang yellow and specificity in red. Okay, recall dekat dalam yellow tu. So ini macam repeat balik je. Kalau you dah faham dekat sini, so tak payah nak imagine yang ni pun tak apa, tak ada masalah. Okay, some explanation about equations. The three additional metrics tadi kan. Accuracy, I'm sure you all dah tahu dah. So sensitivity or recall, we would like to see how good the test is at detecting the positive. Okay, sebab kita nak tengok kan how good our performance, our model in detect the positive punya data. And then specificity, how good a test is at avoiding false alarm. Okay, macam tadi. Ini sama juga kat sini. Okay, and the precision, how many of the positively classified were relevant. So a test can cheat and maximize by this by only returning positive on one result it's most confident in. Okay, so for imbalance, okay, imbalance, kalau kata you ada imbalance, ini yang saya cakap tadi dekat the first slide, second slide first slide ke second slide? Oh, ni. Kat sini, in specific case. Okay, specific case ni merujuk kepada you if you have imbalance class. I know that now current punya trend, most of FYP students dia handle imbalance class. So you need to be very careful, especially kalau you nak buat sentiment, kalau kata tak buat sentiment pakai numerical data pun ada. You need to look at the distribution of the class. Sama ada it has balance distribution or imbalance distribution. So balance and imbalance distribution to basically will affect your accuracy. Okay, because we know bila you ada imbalance data, what will happen, the majority class will dominate the whole process. Sebab you bagi banyak data kan, you feed so many data on that particular class to your model. So you punya model tu pandai lah untuk identify that class. Tapi what happen to the minority, dia akan less trained. Okay, that's why usually dia akan dominate, the majority class will dominate the whole process. So how to use it? You kena tengoklah, kadang-kadang accuracy dia akan drop. Okay, it's okay. Accuracy dia mungkin rendah sikit. Rendah tu tak adalah sampai 40% or 30%. Yang 30-40% tu you need to relook the whole process. Sebab takut ada apa-apa salah kan, ataupun dengan you punya code. If you get 60%, 65% of accuracy untuk model you, then you might need sensitivity and specificity to support your answer, your justification untuk you punya results tu. Okay. Kenapa? Macam saya cakap tadi tu lah, untuk support dan untuk lagi, sebab kalau pakai accuracy, people when they heard 65% accuracy, dia rasa macam alah, macam sama macam you dapat exam jugalah kan, 65% oh grade B. So macam so. Tapi kalau kata you ada some additional indicator that can support that 65%, dia akan jadi lagi strong. Okay, so kalau you buat FYP nanti, please consider that. And this is another example. Okay, kalau kata yang mana actual class, this is predicted class. So actual class we have cancer yes, cancer no, predicted pun cancer yes, cancer no. So we can see that out of all this, macam mana nak kira all these things, specificity, sensitivity and precision. Accuracy tu saya rasa memang tak ada masalah, okay je. Okay, and this is the hold out and cross validation methods. So hold out, as I mentioned just now, we need to split our data set into 2 parts. Okay, 2 or 3 parts. Bergantunglah. Kalau you nak ada validation, then adalah validation. Kalau tak nak pun tak apa, tak ada masalah. Okay. Tapi you need to make sure that your training, you punya split ratio tu must be suitable for your data set. Maksud suitable tu dari segi number of data set that you have. Kalau data set you kecil, jangan guna training data set, jangan guna training set yang rendah. Okay, let's say you have 1000 data. So maybe you need to try a few numbers of split ratio. You can start with 70, 80 and 90. Okay, kalau you have less than 1000, let's say lah, ada some of the students ada data yang like 200, 300 macam tu, or even 100 pun ada. So apa you boleh buat, you boleh try higher percentage untuk training, low percentage untuk testing, atau you can opt for cross validation, K-fold. Okay, K-fold is meant for small data set. Dia sebab apa? Sebab bila kita tak cukup data, kita worry nanti kita punya model tu tak betul-betul train kan. Jadi tolong pakai cross validation. Kalau you ada yang macam tadi lah 100 or 200, tapi nak pakai split ratio pun boleh. Tengok kesesuaian lah. Kalau data sikit tapi you ada kolom yang banyak, jadi high dimension kan. High dimension tapi low instances, you tengok balik which one yang ni. Saya rasa hold out method, in that case hold out method is preferable compared to K-fold, sebab K-fold you dia akan ambil masa kan. So bila you ada banyak kolom tu, dia punya computation time dia akan tinggi. But I don't know, depends on the data. Kalau even though kolom banyak tapi data you simple, mungkin dia tak ambil masa yang lama. So you can try both, which one yang okay. Tapi kalau kata tak nak, you just pick salah satu sahaja. Okay, cross validation. Okay, dia cakap randomly partition the data into K mutually exclusive subsets, each approximately equal size. Okay, kena samalah. So you tengok data you ada berapa, and then you find the most suitable K. Usually by default tools, kalau macam Rapid Miner ke Weka, dia akan letak 10 kan as a default. Okay, so you have to dia macam if you select 10-fold, the 9-fold will be reserved for training and 1 tu for testing. So dia akan rotate kan, 1. So the first akan jadi akan jadi test, the remaining 9 akan jadi training, and then dia akan shift lah. Okay, setiap satu tu akan take turn untuk jadi testing set. Stratified pun saya dah cerita dah tadi. Okay, tapi yang I cerita tadi tu dekat hold out method, but I think you can imagine kalau stratified cross validation macam mana. In each of the fold, in each fold, okay, you kena remain the percentage of classes tu. Okay, katakan untuk ini fold 1, you ada 70% A. Okay. And 30% B. So you kena make sure lah dekat dalam testing punya fold tu mesti ada 70 A, 30 B. Ini B, sorry. Okay. So boleh pilih, tengok macam mana. These are the choices yang you kena buat waktu buat modeling. Okay, next is the selection for ROC curve. So ROC stands for Receiver Operating Characteristics. Okay, it is a visual type lah. Tadi kan kita buat pakai calculation kan, you need to calculate based on the numbers, confusion matrix that you have generate. So for ROC curve, kita plotkan dia dekat dalam graph, and then it's actually originated from signal detection theory. So it will show you the trade-off between true positive and also false positive rate. Okay, beza dia. And then it will rank the test tuple in decreasing order. And the closer to the diagonal line, the less accurate is the model. Okay, let's look at this. Okay, ini diagonal line. So kalau dia dekat dengan diagonal line ni, dia akan kita boleh cakap dia less accurate. Tapi kalau dia jauh, it means that the model is accurate. Okay, so if we have two models, models 1 and models 2, kalau tengok kat sini, we can conclude that model 1 is better than model 2 kan. And kalau you tengok dari segi performance pun, true positive rate dia tinggi compared to model 2. Okay, so vertical axis will represent the true positive, horizontal false positive rate. So you akan ada diagonal, and then tengoklah once you plot tu, you akan tengok which model is okay. Ini kalau nak tengok secara visual. Okay, kalau tak nak, you boleh tengok based on confusion matrix tadi. Atau you nak keluarkan dua-dua pun boleh. Like I said, you have the confusion matrix, you have all the numbers that support you punya results, but you can also have this ROC curve untuk strengthen you punya results tadi tu. Okay. Kalau tak nak, pilihlah salah satu. Okay. Some of the students, they tak pakai confusion matrix. Dia kata, madam, saya nak pakai F1 score and ROC. Okay, fine. Tak apalah, pakailah ROC. Tapi bila ROC ni, you should be able to justify, and then kena analyse sikit lah kenapa model 1, why you said model 1 is better than model 2. Okay, so here, Allah, apa ni? Okay, dia macam tertarik pula, but it's okay. This is ni contoh untuk, kejap lagi saya bagilah dekat you all dekat dalam group the full set of previous questions. So you tengok dan you cuba buat untuk bahagian cross validation. Cross validation pula dah. Untuk bahagian confusion matrix. So these are the examples of questions. I ambil 2 je daripada 2 semesters. Okay, usually Dr. Rahila will rotate je lah. Sebab we all berganti-ganti untuk buat, bukan berganti-ganti, sorry. It's not berganti-ganti. Dalam satu exam questions tu, kita tengok, okay, tajuk ni siapa buat, tajuk ni siapa buat. Usually tajuk confusion matrix ni will be done by Dr. Rahila. My part is usually on MapReduce punya section ataupun NLP. But kalau you tengok nanti, maybe I will give you 6 set of previous semesters punya questions. You will see there are similar questions tapi kita ubah number sahaja. Okay, but basically these are the questions. Kita minta you calculate the accuracy, you need to calculate the misclassification rate, sensitivity, specificity, and then you might also need to explain a little bit about stratified cross validation ke, the stratified methods ke. Dia play around lah, sebab stratified ni is something that, yelah macam saya cakap tadi kan, something that important in doing this analytics. Sebab kita nak kena tengok banyak aspek. Kita bukan develop model sahaja. You need to see about your data, you need to understand. That's why kita belajar data ada section untuk data understanding kan. Before you do the data preprocessing, you need to understand. So data understanding tu will covers also the distribution of the class. Okay, itu sahaja untuk part 2. Tak banyak. Any question? I say you all dah tak ada masalah tentang confusion matrix ni. Dah tahu dah macam mana nak kira. And for these 2 questions tu, mudah sangat lah untuk you buat. Ada soalan?
Assalamualaikum Doktor.
Salam.
Doktor, untuk yang ROC graph tu, kan Doktor kata kalau model satu lagi jauh daripada diagonal line, dia akan lebih accurate kan? Kalau dia lebih jauh tapi dia belah bawah tu, macam mana pula Doktor?
Dia belah bawah? Tak, dia
Dia...
mesti atas.
Oh, dia mesti atas,
Kalau you
takkan
plot
bawah?
mesti atas.
Oh, okey.
Kalau belah bawah tu macam kalau belah bawah maknanya dia jauh daripada true positif lah. Lagi tak okey lah you punya model. Let's say lah we have another model kan. Contoh lah, saya tak tahu so far yang duduk plot tu kebanyakannya duduk atas daripada diagonal line. Tak pernah lah lagi jumpa dekat bawah kan. But ya tak apa. Kita tengok mana dia tadi I punya ROC. Sekejap kita share sekejap. Contoh macam ni, mana dia? Macam ni kan? Kalau dekat bawah ni dia macam ni
Doktor.
Okay, kalau you tengok dekat sini, ini true positif ini false positif. Kita nak tengok, of course kita nak tengok yang dekat dengan true positif. So kalau dekat bawah ni, you tengok dia punya tu, dia lebih kepada false positif instead of true positif. So we can say that, let's say lah ini adalah model 3, we can say that model 3 also, the worst model is model 3 lah. Sebab dia di bawah diagonal line. Okay. But usually, macam saya cakap lah, jarang kita dapat hak bawah ni. Selalu dia atas diagonal line. Tak pernah lagi saya jumpa. Selalu kalau ada pun, dia akan ada yang dekat dengan diagonal line tapi atas. Okay? Boleh
Faham.
Okay, saya nak bagi a few, saya nak bagi nota, saya nak bagi yang tadi tu. Mana pula I letak saya punya. Okay, this is the hold out method. Saya bagi dekat group A dulu Sekejap group B. Saya nak cari notes tadi. Okay, so okay, and I will also give you sample of bukan sample lah, it's actually exam questions. The previous one, you boleh download juga sebenarnya. Ini yang saya download. Mana ni? Okay. So you all boleh tengok. Sekejap saya nak forward ini dekat group B pula. ISP610 group B. Okay, group B dah ada? Dah dapat? Masuk tu? Dah kan?
Dah dapat.
Okay, so now you buat exercise yang dekat dalam exam question yang dulu-dulu tu buat untuk confusion matrix. Boleh? Minggu depan kita tengok apa minggu depan. Tak ingat lah. So you punya next. Okay, lepas analytics method, okay, minggu depan kita tengok NLP. Tak susah pun NLP ni, sekejap je. Naik daripada Christmas, kita akan tengok text analytics. And then habiskan emerging technologies tu, MapReduce and Hadoop. Kalau boleh access Big Data Lab, nanti saya tunjuk dekat you all macam mana MapReduce tu berfungsi. Kalau tak dapat, takut clash dengan ada kelas dekat situ, saya try access bila-bila yang dia available, and then saya akan record buat screen recording untuk tunjuk dekat you all MapReduce tu kerja macam mana. Okay, so yeah, itu sahaja lab exercise you dalam proses. Group A almost done, Group B saya rasa mungkin hari ni atau esok saya boleh habiskan, and then after that saya akan bagi punya results untuk lab exercise hari tu, and then saya akan continue marking you all punya test pula. Okay, so by next week insyaAllah dua-dua saya akan release 30% of your carry marks tu saya akan release markah. Okay? Any other question? Ke semua okay?
Okay, doktor.
Okay, doktor.
Kalau ajar students 259, mudah sebab you all dah belajar dekat dalam data mining untuk part ni. Tapi ajar matematik pun okay juga. Kalau kata saya ajar students lain yang tak pernah belajar data mining, dia macam itulah lambat sikit lah nak kena explain satu, mana nak ambil values apa semua tu. Okay, so cuba buat exercise and then insyaAllah we will discuss during lab. You try buat untuk semua questions yang saya bagi kat you tu 1, 2, 3, 4, 5. There are 5 set of question, tapi janganlah buat set tu. You buat dekat cross validation confusion matrix sahaja. Okay, yang lain tu reserve lah, nanti NLP pun kita akan tengok juga, ambil daripada previous questions juga untuk buat exercise. Okay, so if you are okay, tak ada soalan, so saya nak dismiss kelas boleh sambil, tapi you all buatlah exercise tu. Saya akan ada je kat sini, saya nak continue marking you punya lab. If you have any question, boleh nanti kita masuk balik dekat dalam Teams, ataupun you just text me je lah kat WhatsApp. Okay? And don't forget to tick your attendance. Saya perasan kadang-kadang dah habis kan macam, Madam lupa tick. Ya, saya dah tak notes kat situ. Untuk siapa-siapa yang ni. Okay, tolong pergi dekat your future and tick your attendance. So, I think that's all for today. Thank you. Continue buat exercise tu Saya tak leave lah kot the meeting. I just mute sahaja, tapi saya nak continue marking you punya lab. Okay, kalau you rasa macam you nak leave the meeting, you can leave, and then kalau ada soalan you can join balik, ataupun kalau you nak stay pun boleh juga, tak ada masalah. But please continue doing your exercise tadi tu. Okay, thank you.
Okay, doktor. Thank you, doktor.
Thank you, doktor.